Okay, now we got inscribed angles. Some things you need to remember for this, okay? I gave you an example here. An inscribed angle is an angle with the vertex on the circle. So this arrow is trying to point to B because that's your vertex. And it's on the circle. And an inscribed angle also has an intercepted arc. That's the AC. That's the arc that's between the inscribed angle or the chords, okay? And there's a relationship. This is what's the important stuff, what I have over here. The relationship says that an inscribed angle is always half the intercepted arc, or you double the inscribed angle and it equals the intercepted arc. We're going to use that to do some problem solving. Now, I'm going to go back to doing the left side again to get you to practice on the right side. So on number 30, couple things. Hopefully you see you have a diameter here. So that means it cuts the circle in half, so that's 180. And then C is an inscribed angle, and the intercepted arc that goes with C is that 180. And this is the corollary for inscribed angles. Anytime you have an inscribed angle that intercepts a semicircle, that is always 90. So that's one of the easy ones. If you just remember that, whenever I see a triangle inside a circle with the diameter as the hypotenuse, we're going to have 90 degrees every time. Now, the inscribed angle part is the B. This vertex is on the circle. Here's the angle. The intercepted arc is the 95. It's in between the chords, okay? So to get to B, to get to the measure of angle B, oops, sorry, so I have the highlighter on. B equals half the intercepted arc, which was the 95. So we're taking half of that. So B is 47.5 degrees, okay? So I can put that in there, 47.5. We know C is 90. So to get to my A, I need to use the arc over here, the angle over, because the arc AB is the intercepted arc of the inscribed angle, the other acute angle in the right triangle. So to get to that angle, basically I'm just saying 90 minus, oops, the 47.5. And I just realized it doesn't look like a 0.5 here, so I understand that's a decimal. Okay, sorry. So we're doing that 90 minus the 47.5, or I'm going to do that first. I'm just going to show you. 90 minus the 47.5 will give me the other angle in our triangle, which is the 42.5. So this angle here is 42.5. Or I can use my diameter. Remember, our diameter cuts it into a half circle. So this half is 180. And I can figure that other remaining arc by using the half circle. But if I know that the angle is 42.5, the arc A is double that. So either I'm saying 180 minus 95, or I'm saying 2 times the 42.5. Either way, I get to the right answer. And we should see that A is 85. Okay, A is 85. All right, so we're going to try on, you're going to try 31 to help you. I'm going to just make sure we start with using our 35 degrees and this arc. Remember, that arc is double that 35. Knowing that arc will help you get to the angle X, okay? And then, don't forget what I showed you. Have a right angle, that'll help you get to Y. So there's some hints there. Let's do 32 together, okay? So, I'm going to extend this page a little bit. We have the 80. We have the tick mark. So we have what type of triangle is our triangle inscribed inside our circle? Exactly, it's isosceles. So if it's isosceles, that means these base angles are going to be congruent too. Now the sum of a triangle is 180. Well, if that's 80, what remains? 100. Half of 100, 50-50. So that's going to help me get to my angles, because the first one that's easy to see is that right here, my x. My x corresponds with this inscribed angle 80. To get to x, I just double that 80. So there it is, 160. I'm going to write it on the outside as well. Now, to get to my y, which is this arc here, goes with, yep, that inscribed angle 50. So we're doubling that, 100. And then we already know the other one because we did it. It's going to be 100 as well, okay? So try to do some problem solving on 33. Think back of what we did on 27. That might help you. But you're definitely going to see something like that. And we'll talk about tests like in class, but that's a test like question. And now we can get into converting degrees. So I'm just going to fast forward and go to the next part.